Welcome back to Joe's Computer Museum. Today we're going to take a nibble and bite out of Applesauce, the ultimate in Apple II floppy disk preservation. Warm up the CRT, it's time for another episode. Alright, now before we assemble this, we're going to take this thing apart because, you know, as they say, don't turn it on, take it apart. So this is the Applesauce unit itself. Now I got the unit that takes both the 3.5 inch and the 5 1/4 inch discs, but we're going to be playing with the 5 1/4s today because that's the one that's got the best assembly process. So we will do that first. So this is the unit. Lots of pretty lights and stuff. They use the what is it? The Fractura font, the original Apple font, to do the logo there. You can kind of see that laser etched in there. This is the safe mode switch. Left means it's not in safe mode, and right means safe mode. Basically, when in safe mode, it electrically disconnects the unit from the right heads of the floppy drive, you know, to prevent catastrophic failure in the event of whatever. Link light here lets you know it's linked up to the drive. In use, read and write, pretty obvious there. Back of the unit, we got multiple different things. First off, it comes with its own power supply. It goes in there. It comes with the audio cable. This cable is really simply used to connect the Hall effect sensor, which is this guy right here, to between the unit and the sensor here. Yeah, it connects the sensor to the unit. It plugs in like that. So let's dig inside the unit and take a look at the internal electronics of it. Just a simple number 2 screwdriver to get in here. Number 2 Phillips. 1 screw. And 2 screw. Okay, so slide this apart. Now it's got this back piece here. It kind of comes apart a little tough. It also has a little sticky here to hold this back plane in place so it doesn't flop around in the wind, but that's okay. So we'll flip this over, and here are the guts. So what do we have? Well, the main brain box, if you want to call it that, is going to be this here. It is a teensy 3.5, and I took a look at that and found that what it is. It's basically a 120 megahertz ARM processor with a whole bunch of awesome different things on it. The reason this was chosen, obviously, because the processor's got the horsepower to do what it needs, and it has all of the I/O interfaces required to get the job done. The processor is super fast, and it allows the Applesauce the software on here to oversample the disk, basically to get super accurate high resolution pictures. Basically is what it is. It's a picture of the flux transitions on the original disk, so that they can be very precisely recreated. And the rest of this stuff down here is mainly just glue logic that connects to the I/O pins. As you can see, our primary interface to the outside world here is just this USB cable. But the glue logic helps interface the actual floppy drive here. It deals with the power, the voltages here that are required to run the floppy drive itself. And then it just controls interfacing to the front LEDs and stuff. So, you know, most of the magic glue is happening right here in the teensy board, and this just interfaces with it. As you can see, I have serial number 1047, a relatively low serial number. They probably started at 1,000, if I had to guess, because the first one was like 100 boards. So I'm kind of in the middle of the road there, but that's okay. So let's go ahead and put this back together. Goes back together pretty easy. You know, if you're not an idiot like I tend to be. So this goes in here. Now you need to make sure you get that cable slotted in there, or else it doesn't go back together very well. I found that out first time I was getting in here to take a look at the innards. Goes back together, screws go back in. Now we could run this with the case apart, but you know, I want to put it back together before playing with it. Doobie doobie doo. There we go, back together. We'll slide that out of the way. So the next step is we have to assemble the sensor here, the sensor and the magnet and the cable and all that inside our disk 2 drive. So let's do that next. Disk 2 drive. This is my drive 1 from my Apple II. It's got a broken write protect lever there, but it should work just fine. I have to fix that write protect lever at some point someday. Can we get a better focus on this guy right here? There we go. So you just take the screws out of the bottom, and there's 2 sets of screws you have to take out. First is the outer chassis screws. Those come out, and of course I'm missing one. It's been missing one since the day I got it 20 years ago, so whatever. Slide this out. Now, there's a couple different things you can do regarding these drives. You can modify the original drive you have for your Apple II if you want, or you can just go online and buy another drive specifically for the purpose of this modification, whichever you want to do. However, when the Applesauce is not in use, you can just leave this unplugged. Everything is electrically disconnected, and it doesn't mess with the Apple II in any way. So you can just reuse that drive, no problem. So now we take off the inner chassis screws, which are these bevel-headed insets. And that takes care of the inner chassis, or the bottom chassis, if you want to call it that way. Did something just fall on the floor behind me? A little sheet of paper? Yes, it did. That happens sometimes. Okay. Those are out, and now we can take that apart. Now, I found the best way to deal with this is to just swing this away. Don't try to get the cable out of here. It's a pain in the patoot. You just kind of swing it out of the way. Then you remove your cable, making sure that you note which side is which orientation is. Now, I've gone ahead and pre-marked this because there's no red marking on the cable itself, but I went ahead and I've taken this drive apart before and I've marked that before, so that's fine. So we get that out of the way. And now we are into El Drivo. So the first thing we need to do is actually, if this is the first time you've ever taken your drive apart in a billion years, what you want to do is get yourself a can of compressed air and clean and dust the absolute crap out of the inside of this machine, because it's going to be a dusty mess. You're also going to want some isopropyl alcohol, which I have in a little squirt bottle, and a little cloth. You can use cotton swabs. You can use whatever you want, but you want to use isopropyl alcohol to clean the areas you're going to be attaching these things to make sure that they stick really well. Last thing you want is for things to just kind of fall apart and come out of the machine while you're trying to get things set up. The isopropyl that I like to use is this stuff right here. This MG Chemicals isopropyl 99.9% pure anhydrous. This is just alcohol. There's no other crap in it. You can use drugstore stuff. Try to get the 90% or higher if you can. It's fine. Just like Ina Garten says, if you can't find really, really high-end stuff, store-bought's okay. Bad joke. Anyway, so we're inside the device now. The first thing we want to do is we need to get the drive belt off here. Looks like my drive belt is a little loose. I may need to replace that at some point, but that's okay. This is the original drive belt that's been on here for, 35 years, so whatever. So to get this off, the easiest way to do that is to pull up on this just a little bit, pull up on the drive belt, and just rotate that around until it comes off and pops right off. Super easy. You don't have to stretch the belt or do anything wacky. You want to be, of course, you want to be very careful when you're doing working with this belt, because if you do stretch this belt out, then you're going to have to try to find a replacement belt, which is not impossible, but not the easiest thing to do either. So the belt is out of the way. So now we need to look at this. Now this is one of the this drive is a little one of the easier ones to get this attached, because there is space up underneath here or here, wherever you want to put it, to get the pieces and parts in there. Now, what pieces and parts are we putting in there? Well, we're going to be putting in this Hall effect sensor and this magnet. Now let's talk about that for a second and why we're doing this. So, the original Apple II floppy drive here, the Disk 2, is a piece of electrical engineering genius. Woz, in his infinite wisdom, designed this so that the synchronization of the spinning of the disks so that the Apple II would know where you were on the disk at any one time was done entirely by a specialized encoding of the flux changes of the bits on the disk itself. It was self-synced. That means there is no synchronization sensor whatsoever in this drive. That leads to all different types of problems when you're trying to preserve disks because especially with the copy-protected disks, they have their own built-in synchronization processes. They have intentionally blank areas of the disk. All different types of wacky different things. Again, because Woz's Disk 2 system was software-controlled, you can make the disks do anything. That makes it to where it's very hard for a device like this device here to know exactly where the head is, or where the head is synced up on the rotation of the disk. So we have to add this hardware in so that the Applesauce knows where it is on every pass of that disk and can sync things up. That consists of a Hall effect sensor. If you don't know what that is, go Google it. But basically, a Hall effect sensor it senses changes in magnetic field, and then we add a magnet, tiny little magnet. When the magnet passes over the Hall effect sensor, it puts out a little pulse on this that goes through the wire here to the Applesauce controller, so it knows where it is. Pretty straightforward. So, on this one, the way this is installed, let me get a little pointy device here. The way this is installed is you take a little piece of this guy and you put it up underneath the edge of the spindle here. And then you take your Hall effect sensor and it comes with double side tape. And you just double side tape it down to where it's right underneath where that magnet passes underneath it, but not to where it touches it. And so it'll rotate around and pass over that and help synchronize it. Pretty easy stuff. Now, before you put all this together, a couple little caveats you have to worry about. One, I found that when working on these, many times the magnet here will not pass between this "you shall not pass" joke. It won't pass underneath here. But you have to be careful with that because I found that in the case like, see this drive? See how it's loose? If you look at the way this is situated, it's situated this way. Gravity will pull this down, so there is actually space inside here to fit that if gravity is pulling it down. If you find in that case, though, you always want to check that first and make sure you've got space in there to do that. If that doesn't, you can take a flat-made screwdriver, put it in here, and pry it ever so slightly till you hear a little thunk. You'll feel it pop up, but you don't want to put a lot of pressure on it because then you can accidentally deconstruct this entire assembly in here, and because this is all just pressure fit together, and that would be a bad day for you because trying to get back in there to reassemble that, yeah, I don't think anybody wants to try to do that. So. In this case, as we can see, when gravity has pushed this down, there's plenty of space in there for that to get in there and not catch on the metal bit here. So now what we need to do is use our isopropyl alcohol here, a little bit on the cloth. We're going to clean the area we want to put this in here. I'm going to put it right underneath the 50-60 area, just so I know where I'm sticking it. Nice and clean, and look, it's all yucky and yellow. My parents were smokers when I was a teenager, and so it doesn't surprise me that the inside of this is a little gooky. So then, we also need to clean this area down in here, since that's where we're going to be putting the sensor. So a little more alcohol on there. Clean this entire area. Sure it's nice and clean, no dust, no ickies, no anything that's going to cause problems with that double side tape sticking and staying stuck forever. Now that area not as bad. So we will let that dry as we sit here and sniff the wonderful vapors of alcohol. Okay, so now we need to put the sensor on, or the magnet on here, and the way we do that is we cut a little piece of it off and we stick it up on there, and it has to be basically aligned right to the edge of this here for best accuracy. It doesn't have to be perfectly aligned, but if you put it right up against the edge of this, it's easier for you to see what you're doing. So I just need a tiny little bit. It's about the same size as this sensor. So about like that. That should be fine. So that's all we need, that little bitty bit. And we take that. And I'm going to use tweezers for this. But you know, you can just manhandle it if you like. But I like being accurate and all nerdy and techy. So we use the tweezers. You get it aligned right up on there. And there we are, and then press it up. Okay, there we are. Can you see that on there? Aligned right to the edge. So now we need to get this guy aligned. Now this tape is like the worst. It sticks and does not move. So you're going to want to make sure you get this all figured out and aligned exactly where you want to go. And it's got to be right underneath the sensor. Now remember, we're gravity feeding this thing downward. Or I should say, you know, gravity's going to pull this down, so we need to make sure that when we're putting this, we're pulling up on that to where it's in its final position before we align this, because this sensor needs to nearly but not quite touch that magnet. So you just keep bending and figuring it out until it's where it needs to be without touching, but being insanely close. And that is pretty good. I think I want that a little bit higher, just a little bit. There we go. Pretty close, but still too close. There we are. One final little adjustment. I think it's tweaked to one side a little bit. There we go. This is a little bit squirrely trying to get this adjusted. There we go. I think that's good. Now that we have that, we can pull our adhesive tape off. Now, I will admit I did this. I've done this already on one of my other drives. I had to actually rip this off, and I have new adhesive tape on here because while I was recording my first run of this, my camera, the moment I pressed stop on the camera, or my iPhone, it crashed, and I lost 20 minutes of footage right about at this point. So we need to get this underneath here, get it aligned, stick it down, and it is good. Now we can see that it's hitting it's hitting the sensor, but that's okay because remember, when it pulls by gravity, it's going to pull it down and it's going to spin free. So if we pull this down and spin it, you can hear it spins freely, but doesn't hit it. So that's perfectly fine. So now, what we need to do, we need to get this cable routed in here. And I found the best place to put this cable on this particular disc 2 is just to route it up through where the rest of these power cables are going. So we just kind of stick it up in through here, like, let's put it down through. That might be easier. Okay, bring it all the way out. And this guy just plugs in right there. And the sensor is installed. So now we got to route the cables back out. And we'll want to try to route it back out route it back out through the same slot here that goes through, obviously. So let's get this all situated. This goes in here like this. This goes here, making sure to get it keyed correctly when you plug it in. And then we can take this cable and just kind of route it up and over. Should be just fine like it right in there. Now, We want to spin this to make sure everything's clear. And then I also look down through here just to make sure it's not going to get caught in any mechanicals or anything that move. And we should be okay. All right. Now, get the original beveled screws put back in here for the bottom plate. Yes, I know, I forgot to put the belt back on the drive. Don't worry, it's back in there now. And of course, standard, you do these loosely first until they're all indexed, then you can tighten them up. Now these beveled ones are smart because beveled screws are auto-centering. There's those. Make sure our cable is through here where we want it to be. It is. Now, we put the bottom, or the outer chassis back on. It's not always simple, because it is a very tight fit. There we are. And again, put these in loosely to get them indexed. You don't want to tighten them all the way until they're all in. And again, normally you would have 4 screws in yours. Mine has 3. It's always had 3. It's been missing this screw since I got it in 1994. And there you go. All assembled. All in there and ready for the magic. So, let's plug it into our Mac and take a look at the software side of the Applesauce. Before we get started with the software, though, let's show you how everything hooks together. Here is the Applesauce. It usually just sits on top of your drive. Power goes in right here, right into that unit. Your floppy cable goes right here, making sure that the red line, your red cable line, is on the left. Now, this connector is keyed, and you can see there's a key notch in here, so it'll only go in one way, but not all those connectors are keyed. So it's important to know red goes to the left. And then your index sensor, your Hall effect sensor audio cable thing, goes right there. That plugs in there. And then this guy right here, your USB, plugs into the Mac. And that's all there is to it. Now let's play with the software. Updates, updates, updates. The software detects if your unit needs a firmware update and will do it automatically. This is important to ensure the hardware can read and write more accurately. It's a cool feature. It doesn't seem yet to check for updates to the software itself, so you'll want to check out the project site frequently. There have been several bug and feature revisions already, and there's sure to be more in the future. Let's look at the features. The calibrate function ensures your drive speed is set properly. You'll want to run this first and calibrate with a disk in the drive so you get an accurate reading on speed in normal circumstances. To adjust the speed, just run the calibration and adjust this potentiometer until it reads 300 RPM. The MC3470 noise analysis function is next up. This tests the floppy interface chip. As an analog device, it's susceptible to various interference sources, manufacturing variations, and age. This function allows you to see how well your chip will work at reading disks. Lower numbers are best. I happen to be lucky and have a very good drive for imaging. The Fast Imager function does what it says, creates a WAS image file from any standard formatted Apple II disk in about 12 seconds. But the Flux Imager is where all the magic happens. This feature takes a high-resolution, oversampled Flux transition image, allowing you to accurately preserve any Apple II disk. Copy protection, weird sync marks, funky formatting, quarter tracks, none of that matters. The Flux Imager gets it all. The disk editor allows you to play around with images on the nerd level. You can hack your images to your heart's content. Remove copy protection, maybe? Most folks, though, would use this to export Flux images to WAS images, for use in emulators, and eventually for writing back to original disks. The disk editor plays well with many kinds of copy protection, but it doesn't know how to read them all. Flight Simulator 2, for example, is a hot mess. But even though the software can't interpret it now, doesn't mean it won't be able to later. Since the raw Flux image never changes, all that's needed is a software update, and eventually we'll be able to export this one too. As a quick aside, for some idea why Applesauce can't interpret Flight Simulator 2, I have a link in the description to a magazine article explaining the copy protection scheme. It's very non-standard. And finally, the disk writer. Right now, it can write DSK and PO images, so if you want to, you can download images and pop them straight onto floppies. But it does not support writing WAS files yet, as there's still some quality testing left to do. Writing WAS images is coming very soon, and would be what I would expect in order to make the product feature complete. Let's look at other hidden gems in the program. Diagnostics. A cool thing to test your setup and ensure everything is working correctly. But I suspect this is for the developer's internal use. The metadata inspector allows you to edit metadata of the files you've already created. Neato! The Visualize Disk option creates a PNG image of the data in an image file. For artistic reasons? And the bulk processor does all of the items already noted, but on multiple files automatically. On a whim, I decided to see if it could image floppies from other systems. Here's an Atari 400-800 series disk, and a Commodore 64 1541 formatted disk. How about a CP/M disk? As a matter of fact, it looks like it can image just about anything I throw at it. But just because I get a result on the screen doesn't mean it can do anything with a particular disk format, even down the road. However, since this system does a crazy good job of capturing high-resolution images of the disks and is entirely software-driven, I wouldn't rule out the technical ability to read any disk the Apple II floppy drive has the resolution to capture. Final thoughts? The Applesauce floppy disk controller is freaking awesome. This should be the last solution ever needed for preserving all Apple II disks, unmodified and uncracked, forever. Flux-level digital backups of floppy disks for permanent preservation? You can't ask for more than that. Keep in mind that at time of recording, the software only runs on a modern Mac, so if you don't have a Mac, you'll have to hang out for a bit until a package is completed for Windows or Linux. My only complaint is documentation. At time of recording, documentation is scant. If you're not already familiar with the project and many of the aspects of how Apple II floppies work, or if you're not mechanically inclined, the build process and some of the terminology may not make sense. However, by the time the next hardware run is ready, I suspect documentation will be complete. It should go without saying, if you have old Apple II floppies you want to preserve forever, get an Applesauce FDC the next time they come around. You won't be disappointed. Well, that's all for today's episode. While you're here, check out some of my other videos, and remember, 8 bits are all you need. Thanks for watching. If you want to help out my endeavors, head on over to Patreon, pick a tier, and get cool stuff, like early access, behind-the-scenes videos, your name in the credits, and gadgets. Link in the description. I'm unclean, a libertine.